Hello everyone. Today we'll be going through sample paper Cambridge IGCSE Physics 062502, and this paper is for examination from 2023. Let us go through this specimen paper. This is containing 40 questions and all are multiple choice questions. So question number 1, a length of string is measured between 2 points on a ruler. So ruler is provided and these are the 2 points. One point is over here and the second point given is here. We have to take readings and carefully we have to take reading from here, this initial point and this final point. So if we check the final mark, it is 15.6 and initial point is 2.4. So we can, if we subtract these two, we will get this calculation 15.6 minus 2.4, which is equal to 13.2. And they are saying after making this calculation, when the length of the string is wound closely around a pen, it goes around 6 times. So there are 6 turns in this one, so we have to divide this complete length of the string by 6, and if we divide 13.5 by 6 we will get 2.2, and this is our answer A, which we have already highlighted. Hopefully you understood this question. And now if we go through question number 2, when does an object falling vertically through the air reach terminal velocity? So we have to understand what do we mean by terminal velocity. Terminal velocity is when a body is moving under the gravity, and it is, for example, in this case we are discussing a ball is moving under the gravity. Weight of the ball, which is mg, will be acting downward and drag force will be upward. So when weight of the body will be equivalent to drag force, at that moment body will be moving under the action of gravity only, and that will be the terminal velocity of the body. Now after understanding terminal velocity of the body, if we go through this C option, which is when the air resistance equals the weight of the object, so that will be the option which we have taken C, when the air resistance equals the weight of the object, which we have taken from the definition of the terminal velocity. Now question number 3, an athlete runs a 100-meter race in a straight line. 100-meter race in a straight line. The table shows how his speed changes with time for the first 5 seconds of race. So 0 speed at 0 second. Initially it was having 0 speed, then at 1 is 1.7, 2 4.1, 3 5.7, and they have given this table. Now what is the average acceleration of the athlete between time 2 seconds and 3 seconds? So we will have to check 2 seconds and 3 seconds is this interval, and in this interval we will calculate the speed, basically 5.7 minus 4.1. This is change in speed. So we have calculated change in speed, and change in speed divided by time will be the average. Basically change in velocity over time is average acceleration, so which is 1.6 we have calculated over here, and the option is A, which we have taken over here. Now the question number 4, the gravitational field strength on the moon is 1.6 Newton per kilogram. This much is the gravitational field strength. An astronaut has a mass of 75 kg. So what is the weight of the astronaut? So weight will be multiplied by weight 75, mass, basically mass will be multiplied by the gravitational force. How we are calculating weight W is equal to what? W is equal to M into G. So M is mass and G is the gravitational field strength, which is 1.6 in case of moon. So we will be calculating like this one. 75 into 1.6 will be equal to 120 newtons, and 120 newtons is this option C, which we have taken over here. Now question number 5. Two objects P and Q are placed in a beaker containing a liquid. Object P floats in the liquid and object Q sinks. So P is floating and Q is sinking. Which row of the densities of P and Q and the liquid is possible? So density of P will be 11.3 because it is floating, so density will be lesser, and Q is sinking, so its density should be higher than the liquid. So density of liquid is 13.6. So we'll have to check from here. So the object which is floating should have density lesser than 13.6, and an object which is having density higher than that will be surely uh, sinking in that one. So according to this one, if we check the other rows, they are not following this rule. Now the ball of mass, question number 6. A ball of mass 0.12 kg is hit by a tennis player. The velocity of the ball changes from 0 meter per second to 5.0 meter per second in this much time. What is the average resultant force? So average resultant force we have to calculate. And in explanation, we know F is equal to ma, force is equal to mass into acceleration. So acceleration is what? Change in velocity over time. So we can write acceleration is equal to change in velocity over time, like this one. So acceleration, change in velocity is what? Change in velocity is from 0 meter per second to 5 meter per second. So 5 meter per second, 5 minus 0, and this will be divided by the time duration, which is 0.6 second. So 0.6, and this calculation we have done over here, which is equal to 8.33. Now F, this is acceleration, so F is equal to mass, which is 0.12, which is provided over here, and it will be multiplied by this acceleration which we have just calculated, and we will get 1 Newton. So 1 Newton option is A, so we have chosen 1 Newton as A. Now, question number 7. A balloon and a mass are attached to a rod that is pivoted at a fixed point P. So this is fixed point, pivot point, and balloon is this one, and mass attached is this one. So the question is, the balloon is filled with helium. So helium mean this balloon is filled with helium. So it will be pulling it upward, because helium, is lighter than air. So it will be exerting force upward. So this will be having this is pivot point P. So this will be trying to turn it to this side, which is clockwise, and mass will be having force acting downward, weight will be acting downward, and it will be turning to like this direction. So we can say that it will turn to this direction, which is anti-clockwise. So there is a clockwise turn and anti-clockwise turn also. So we'll calculate both the turns. Balloon filled with helium applies an upward force, they have explained over here, and the rod is horizontal and in equilibrium. So equilibrium means what? Equilibrium means clockwise torque is equal to, or clockwise moment is equal to anti-clockwise moment. torque and moment are basically the equivalent words. Which equation causes the rod to rotate clockwise? Rotate clockwise mean it is this will be moving clockwise. We will check how it will be moving clockwise. So clockwise movement is equal to anti-clockwise movement, which is this rule which we have discussed. So m is what? Mass into mass over b is equal to b is over here. So mass over b is equal to 40 over 3. Basically this one, this is the equation. Mass into 20, mass into 20, which is this one, this mass, this one, and 20 is arm of the force, distance from the pivot point, and mass into arm of the force is equal to this force balloon, and arm of the force from here is 30, so it will be multiplied by 30. Hopefully you understood this equation. So shift b to the other side, so m over b is equal to 30 over 20, which is equal to 1.5. Now if we check, calculate for all, moving the ball, moving the balloon to 40 centimeter mark and the mass to 30 meter mark. If we are doing this one, we will get this much. M over B ratio will be 1.333. Now we have calculated for all four options. We have calculated over here M over B ratio, and if you check, B option is giving this one 2. So B M over B ratio will be 2 for B. So move, this will be the correct option. Moving the balloon to the 20 centimeter mark and the mass to the 10 centimeter mark. This will be the option in which this will be turning clockwise. Hopefully you understood this question as well. Now question number 8. A hole is made in square tile. This is a square tile. Hole is made in a square tile of uniform thickness. The diagram shows the tile hanging loosely on a nail. So it's hanging loosely, and this is the nail hole which they have indicated over here. And where is the center of gravity? So if we draw the line, I have drawn a line in green color for you. This will be like this, and similarly if we suspend from a point, we can draw a straight line, and the third line also I have drawn from C. If we suspend from the object at C, so it will be nail at C, so it will be also passing through. So all three colored lines are intersecting at point D. You can see they all are intersecting at D. So this will be basically the center of gravity, which we have to highlight, which we have basically highlighted this D option also. Now question number 9. An object of mass 0.16 kg is moving forward at a speed of 0.50 meter per second, and a second object mass 0.10 kg is at rest. So this object is at rest and this is moving with this much speed. So the first object strikes the second one. After the collision, the second object moves forward at a speed of this one. So what is the speed of the first object after the collision? This is what we have to calculate. So the situation we have discussed over here, before the collision and after collision. So before collision, object will be first object will be having mass of 0.16 and velocity is 0.5 meter per second, and the second object is mass 0.10 kg and velocity is 0 because it is at rest. And after collision, the masses will remain same, but after collision velocity of the second object will be 0.5, and for the first object we have to calculate. So, and we know that the moment after collision before collision is always equal to momentum basically, momentum, not moment. Momentum before collision is equal to momentum after collision, which we can write m1 v1 is equal to m2 v2, or this one, or we can say that the momentum of the system will remain constant. So we'll calculate m1 v1 plus m2 v2 total momentum before collision, which will be mass into velocity. So 0.50 multiplied by 0.16 will be for mass 1, and second object will be having zero momentum, so 0.08 will be momentum before collision. Now we'll calculate momentum after collision, m1 v1 plus m2 v2, and after replacing the velocities and the masses we will get 0.08, and this should be equal to 0.08. So v1 is equal to, after simplification we got 0.187, which is closer to option B. So we have chosen option B. Hopefully you understood this as well. Now question number 10, the object is at rest at the top of a hill. The ball rolls, a ball basically is at rest and it rolls from the hill. At the bottom of the hill the ball hits a wall and stops. So this is wall and it will be rolling like this side and it will be hitting this. So at the maximum position gravitational potential energy will be maximum and kinetic energy will be minimum. So and after rolling, before just reaching to the like resting position, it will be having gravitational potential energy will be minimum and kinetic energy will be maximum. So at the bottom of the hill the ball hits a wall and stops. Which energy change occurs? This is our question. And gravitational potential energy will be when it will start rolling from here. So gravitational potential energy, which we can write G PE, will be basically shifting to kinetic energy, and then kinetic energy will be changing to internal energy. So this will be basically the flow of the change which is given in option B. So we have chosen option B. Hopefully you got this question as well. Question number 11, a man climbs a ladder. Which quantities can be used to calculate the useful power of the man? So useful power of the man, we know power is equal to work divided by time. So the option C is saying the work done by the man and the time taken. So these are the two quantities which we are using for calculating the power of work and time. Basically we are using how quickly a person is finishing the work, that is power. So option C, this is straightforward. Now question number 12, a student uses her thumb to push a drawing pin thumbtack into a notice board. The pin goes into the board but does not penetrate her thumb. Which statement explains this? This is the situation. So surface area of like tip on this side will be very small, and if you check thumb pin is like this one. So surface area at bottom position is very less and surface area on the top is more, so that's why it's not. The pressure will be shifted on this lower position which is having very small area in contact. So pressure of the pin on the notice board is greater than the pressure of the pin on her thumb. This will the option which we can take in this case. Hopefully you understood this as well. Now, question number 13, a submarine is a boat that can travel below the surface of the sea. A submarine is 20 meters below the surface of the sea. The pressure due to seawater at this depth is P, and we know P is equal to rho g h in case of fluids, in gases and liquids. So on other day, the submarine is 26 meters below the surface of fresh water. The density of seawater is given 1.3 times the density of fresh water. What is the pressure due to the fresh water at the depth of 26 meters? So it will be P, it will be P. Why it will be P? Because pressure rho P is equal to rho GH. So P is equal to pressure, density of the gas or a fluid, and acceleration due to gravity will be 9.8, and height of the column of the gas or the fluid. So it's depending upon rho GH. So this will be P, and we will not be multiplying it with any other factor. The submarine, which will be 20 meter below the surface of the sea, and the pressure due to sea water at this depth is P, and on other day it will be 26 meter below the surface of fresh water. So the density is 1.3 times the density of fresh water. So in that case, pressure will be P, which we have taken over here. Now question number 14. When particles of a gas collide with a wall of a container, the wall experiences a pressure. So what is the cause of this pressure? You know, these gas molecules are in random motion, they are moving, and due to this motion they are hitting to the walls of the container also, and they are having zigzag motion like this one. So they are hitting to the walls as well, and after they are colliding with each other also, and they are having zigzag motion. So the change in momentum of the particles, because when they hit to the walls of the container, they are exerting force on the walls of the container. So the change of momentum is happening, because they are having momentum. So when they hit to the walls of the container, they are transferring momentum to the energy to the walls of the container. Now, question number 15. A substance can exist in three states, and they have provided solid, liquid, and gas. So, solid, liquid, and gas. Each of the two states below describe a change in state. Change 1 is particles move much closer together but continue to travel throughout the substance. So this will be basically, it will be condensing, because spaces are coming closer and spaces are lessening. Change 2, particles stop traveling throughout the substance and just vibrate, and we know this property is for solids. So this is solidification and this is condensation or liquefaction. So we have taken option B. This will be condensation and solidification. I've given this drawing also. You can see solid is packed molecules, whereas liquids are moving within the liquid, and molecules are moving and sliding past each other. Whereas in gas, they are occupying the whole space and they are randomly moving in all directions. Question number 16. Copper is a type of metal. Copper is type of metal. A block of copper has a mass of 2 kg. The block of copper absorbs this much joules of thermal energy. The specific heat capacity of copper is 385 joules. And we know specific heat capacity is delta Q is equal to mc delta T. And what is the temperature rise in copper? We have to calculate temperature rise in copper. So delta T we will be finding. This is 12,000 will be change in energy. delta Q, this one 12,000 joules they have provided, will be equal to mass is 2 multiplied by C, which is specific heat capacity, 385 also they have provided, and after simplification we'll get 15.58, and this is closer, option A is closer to the answer. So question number 17, the diagram shows the gap between a hot surface and a cold surface. The gap can contain air, gas, and iron, solid, and vacuum, or water, which is a liquid. So this gap can contain any of these three things. Which material in the gap allows the quickest transfer? So quickest transfer will be in case of good conductor, and we know that good conductor is iron, so good conductor we have taken option B. And we know that this is like explanation. We know the metals are having free electrons, mobile electrons, or you can say delocalized electrons, so they are good conductors, so this will be option B in this case. Now we can go through question number 18. Which row about boiling and about evaporation is correct? And if we check option C, it's saying takes place throughout the liquid. This is boiling. Boiling is happening. If you check this diagram I have provided for you, the boiling is happening. Bubbles are forming inside the liquid also. And evaporation takes place only at the surface. Now this is evaporation which is happening only at the surface, and that's why we have taken option C, which is the correct option. Now let us go through question number 19. Question number 19 says light travels at a speed of this much in a glass block. In the glass, the wavelength is also provided. Find the frequency. We know V is equal to F lambda. This is the equation which we'll be using. V is velocity, F is frequency, and lambda is wavelength. And if we replace the values, F we will be getting is 5.0 into 10 raised power 14, which is option D. And these calculations are provided over here. You can use calculator for simplifying this one. Hopefully you got this. Now question number 20, in a shallow tank a water wave moves through a barrier with a narrow gap. So the diagram shows the waves on the left hand side and the right hand side of the barrier. So these are water waves, and this is the water front they have shown, and they are passing through this hole, and after passing through this hole, these waves are bending like this one as they have shown. So we'll go through the definition of the diffraction. What is diffraction? Diffraction is defined as the bending of waves around the corners of an obstacle or through an aperture into the region of geometrical shadow of the obstacle or aperture. So this is basically the diffraction process which is shown in this diagram. So we'll take option D. Now question number 21, which statement describes monochromatic light? Monochromatic light is what? Is light of one type, only single frequency. If you check this monochromatic light definition is what? Is that has one color that has further broken down into narrow wavelengths. So if we go through option B, light that has a single frequency, this is option B which we have taken. Question number 22, an object is placed 8.0 centimeter from a thin converging lens of focal length 5. So focal length is 5. Diagram is provided. This is focal length, and this is 8 centimeter is basically object distance from the lens. So which statement about the image formed by the lens is correct? So to understand this one, we can go through this drawing which I have provided over here. This is object distance, which is P, and image distance will be Q, and we know the rules of rays. In case of lens, this ray will be from the object to the lens, and it will be passing through the focal point, and then this one straight passing to the center of the lens will be going straight without changing its path, and this one another ray which is passing through the focal point. So this will be the ray, and these will be the direction after passing through the lens, and we can see they will be meeting at this point, and this point we can draw the image, and image will be over here. Now we can discuss image is real and inverted. Why real and inverted? We know the condition that the if image is on one side of the lens and object is on the other side of the lens, then it will be real. So this is real, and inverted, as you can see, this is inverted also. So this is option A which we have taken. Question number 23. A ray of light travels through transparent plastic to air. So transparent plastic to air. So from denser to lighter medium. Keep in mind, from denser to lighter medium. So this is the situation. This is denser medium, and this is less dense, or you can say lighter medium. So this is normal. They have drawn normal also, incident ray and refracted ray. So angle of incidence is I, angle of refraction is R. So n is equal to sine I over sine R. We will be using this formula, and n is equal to what? Refractive index, angle of incidence, angle of refraction. So in this case, it will be 90 degree, and sine I will be 90 degrees. So we will take sine 90 degree over R, and which is equal to 1.25, which is provided over here, and we can find the value of R, which is 53. Calculations are provided, you can use calculator for that, and this is basically the option which we have taken, option D, which is 53. Now, question number 24. What is the speed of electromagnetic waves in a vacuum? And vacuum, they have provided basically in kilometers per second. If you convert this kilometers per second, this is conversion which I have shown. This will be 3 into 10 to the power 5. So if you count the zeros, these are 5 zeros. And if we convert into kilometers to meters, we will get this one, and this option is 3 into 10 raised to the power 5 kilometers, which will be this much. This is basically 3 into 10 raised. Normally we are saying 3 into 10 raised to the power 8. This is in meter per second. So if you check on this side, these are 8 zeros. These are 8 zeros. So we are basically just a conversion we have shown. So this many meter per second will be, if we convert, it will be option B, which we have taken over here, option B. Now question number 25. A pulse of sound is produced at the bottom of a boat. Bottom of a boat is this area, this one, bottom of the boat. The sound travels through the water, so it will be going down, and it will be after rebound, it will be coming up also. Now this is the question is what? Use this information. The sound reaches to the boat. This one we have to go through. The sound reaches to the boat again after 1.3 seconds. The sea bed is 1000 meters below the boat. So the distance, total distance it will be covering will be 1000 going down and 1000 going up. So it will be 2000. So we have taken distance. Speed is equal to distance over time. Speed distance will be 2 into 1000 and divided by 1.3, and answer will be this much. which is closer to option C, which we have taken over here. Hopefully you understood this also. Now question number 26. A sheet of ice floats on water. A source of sound S is, this is sheet of ice over here, and source is this one, and source S is positioned at the edge of the ice sheet. Four microphones are placed. So 1, 2, 3 and 4 is over here. So this is inside the liquid, and source is over here. So four microphones are placed equal distances from S. Which microphone detects the sound from S first? So we will be taking option B. The reason is what? Reason is that sound travels in solids at a higher speed. So if you check speed of sound in solid, like for example, iron is more, lead is lesser, water is lesser, ice is 3980, and air is what? 330. So water is very less as compared to this one is water. This is lesser as compared to ice. So that's why it will be reaching to option B. So the mic B will be getting quicker response. So recording the voice earlier. So we have taken option B. Now question number 27. The diagram shows a bar magnet. So a bar magnet, this diagram is showing bar magnet and four plotting compasses. Okay, so these are A, B, C and D plotting compasses. Which compass correctly shows the direction of the magnetic field due to the magnet? Now we have shown this diagram, north south, this magnet. Magnetic lines are always traveling from north to south, so direction will be from north to south. So if we check from here, it will be moving, like for example, this side to this side. So direction will be showing like this one. So it will be this direction, right? It can't be this one, it can't be this one or this one. So we have taken option D. Hopefully you understood this question as well. Now question number 28. A plastic rod is rubbed with a cloth. This one, the rod comes positively charged. What happens to the plastic rod, and what is the charge on the cloth? Now this is the situation when a plastic rod is rubbed with a dry cloth. We have either one of the following cases. So flow of electrons will be from rod to the cloth, and in this case plastic rod will be positively charged and cloth will be negatively charged. And the second option is that flow of charge is happening from cloth to rod, and it will be negatively, plastic rod will be negatively charged and cloth will be positively charged. In both cases you will have to keep in mind that the flow of charge is just for electrons, not for protons. So plastic rod loses electrons and it will be negatively charged, which is option C we have taken. Hopefully you understood this explanation as well. Now question number 29. The electromotive force EMF of a mobile phone battery is 3.7 volt. What does this mean? EMF is what? EMF is electromotive force. So it means that 3.7 volt means what? 3.7 joules of energy will be handed over to 1 coulomb of charge in 1 second. So option C is saying 3.7 joules of energy is provided by the battery to drive a charge of 1 coulomb around a complete circuit. So E is equal to, you can say, V into Q. Q is charge measured in coulombs and E is the energy measured in joules. V is voltage. So this is basically the relation which you will have to keep in mind. Hopefully it's also clear. Now question number 30. A computer engineer wants the speed of a fan to increase when the temperature inside a computer increases. The engineer knows that a larger current causes the fan to turn more quickly. So, what component should be placed at X to make this happen? So, we at X, what we should be attaching over here? We will be attaching thermostat. And what is a thermostat? A thermostat is a type of resistor. Thermostat is a type of resistor whose resistance is strongly dependent on temperature. So we will attach here a thermostat, which is basically the function of thermostat is what? Its resistance varies with the varies strongly, it's varying with the change of temperature, so it will be thermostat. Now, question number 31, a water heater is connected to a 230-volt supply and there is a current of 26 ampere in the heater. It takes 20 minutes to heat the water to the required temperature. How much energy is supplied by the heater? And to calculate energy, we have this relation: E is equal to IVT and E is equal to IVT. This relation will be using, and replacing value of E will be 7176000, which is closer to the option D, and we have chosen option D. You can use calculator for this calculation. Question number 32, an electric kettle has a metal casing. The cable for the kettle contains a wire that is connected to the earth pin of the plug. So from this diagram you can understand, if this is earthing process is done, it will be safer in case of any short circuit. The easier route will be taken by the current and the current will not be passing to the person who is touching this one. Case becomes live and 230-volt is the alternating current. Metal wire touches the metal case and in that case it will be the casing of the kettle becoming live. This will be the reason for this one. And we can go through question number 33. An electric current can produce a heating effect and a magnetic effect. Which row shows the effect that a relay uses and one application of the relay? For that one you need to understand basically the relay, and if I increase the size of this relay, you can see this is the relay and this is a movable contact, and the most important is basically this portion, which is electromagnet. Electromagnet will be attracting, will be magnetized. Electromagnet is what? Which is temporarily behaving like a magnet when current is passing through the coil. So this is soft iron piece which will be changing to magnet and it will be attracting this movable armature, and it will be touching to this stationary contact, and this is basically relay switch is used to switch on circuits. So magnetic effect is used and allowing a small current to switch on a large current. This is basically the purpose of magnetic this one relay basically which we are using. Now question number 34, the diagram shows a bar magnet and a coil of wire. This is a bar magnet and coil of wire. This is coil of wire, this is bar magnet, is moved at the same direction in each experiment. So, in which direction is the largest electromotive force EMF induced? So, if we move this magnet and coil to this direction and opposite directions, they will be producing maximum EMF. So, which is option C, which we have taken, and the diagram is also explaining this. Now, question number 35, increasing the transmission voltage in transmission cables reduces power losses. And what is the explanation of this reduction? And you can see this graph also. This side is what? Losses by voltage class per 100 miles for given power megawatts. So losses, this is 345 kilowatt, and this is 500 kilowatt, this is 700. So losses will be lesser. So what happens? The current decreases, the amount of current decreases, because charges will be carrying more energy. So when amount of current will decrease, the resistance will decrease. And when the resistance will decrease, there will be lesser resistance in wires, so there will be lesser loss of energy which will be happening. And the same point which we have taken over here, option A for question 35. Now we can go to question number 36. There is an electric current in a straight wire in the direction into the page. Direction is into the page. This produces a magnetic field. So you will have to keep in mind this direction. This produces a magnetic field around the wire. All the field lines are circles, but only one field line is shown. So they have shown one field line. This is magnetic field line, and this is wire with current into the paper. And this situation you will have to understand, which I have shown over here. This point is showing into the paper, right? And this is into the, if it is into the paper, it will be shown as cross. And by Fleming's right hand rule, right hand grip rule, if we move, place our right hand like this, so thumb will be showing the direction of the current, and our fingers will be showing the direction of the field. So in that case it will be this situation. And if it is out of the paper, so a thumb will be upward and fingers will be curling to the anti-clockwise direction. So this will be the situation in that case if it is out of the paper. Out of the paper we are showing with a circle and a dot. So option we will take is D, which is clockwise, more widely spaced, because they will be more widely spaced further from the wire. So what happens if we have to draw, like for example this one? So inner circle will be closer and gap will increase like this one. So gap will be increasing. These are like shifting. I can draw, like for example, you understand that this distance will be increasing. This distance will increase when we move further. For the next distance will be bigger circle like this. So hopefully you understood this as well. Now question number 37, the diagram shows emissions from a source passing into the electric field between two charged plates. So two charged plates, this plate is positively charged and this plate is negatively charged, and this is basically the source. And the diagram shows emissions from a source. Okay, so what is the emitted, what is emitted by this source? How we will understand? So from this property we can see there is something which is attracted towards this negative plate. We'll have to basically understand this diagram, and I have given this explanation. First I'll go through this diagram which is provided by the paper. So something is attracted by this negative plate, so it's bending towards negative plate, and something is influenced by the positive and negative plate, and it's going straight without any deflection. So there are two things, one and two. So if we go through the deflection theory, deflection by magnetic or electric field, this side is positive, this side is negative as provided in this drawing. So alpha particles will be moving to this one. You know, alpha particles are what? Alpha particles are helium nuclei. So they are positively charged and they are moving towards the negative plate. Beta particles are electrons, so they are moving towards the positive plate. So this will, they will be deflecting upward. And gamma rays, gamma rays are neutral. They are not influenced by the electromagnetic fields. So gamma rays will be moving straight. If we go through option C, it is saying alpha particles and gamma rays only. This is what we have seen in this diagram. There is no deflection like this one. So if there is deflection like upward, then we can say that beta is also there. No, in this case beta is missing. Only alpha and gamma rays, alpha particles and gamma rays are there. Now we can go through question number 38, which is which row in the table describes the process of nuclear fusion. You should know this fusion process, and indicates the change in total mass of the particles involved. If we understand the fusion, basically this is the fusion. So it is what happens, we are taking one deuterium, which is isotope of hydrogen, and one tritium, and fusing them together. So they are fusing, and one helium atom is produced and one neutron is formed, and this is releasing a lot of energy also, and this process is known as fusion. By the way, the same process similar to that one process is happening in at sun also, and the source of energy of the sun is this process which is known as fusion. And also, just by the way, I'm just mentioning that the scientists are doing research on this process. This is the future of solution of energy for our earth energy requirements also. But research is going on. It's difficult basically to achieve the temperature and pressure, because it requires a lot of pressure and temperature. So we will not be going into detail. We are discussing this one. You understood the fusion process. And if we take the process, option C, two small nuclei combine to form a large nucleus. So this is basically the option which we have discussed over here in case of fusion, which is explained in this diagram. Question number 39. The orbit of the moon around the earth is modeled as a circular path of radius this much. The orbital period is this days, or you can say 710 hours. What is the orbital speed of the moon? So we know that basically 2 pi r, this will be 2 pi r. So radius of this circumference of a circle, this is circle, so circumference, this is basically, for example, this is r. So 2 pi and r will be the circumference of this circle, and if we replace the values, and this will be the if we start from this point and take a complete round, we will have to cover this much distance. So orbital speed will be divided by time, so distance divided by time, and this will be in kilometer per hour. So which is option D. Hopefully you understood this also. So I'm trying to cover as detailed as possible. Hopefully you are understanding. Now this is the last question. Before going to the last question, keep in mind you will have to subscribe the channel, and you will have to recommend this channel to your friends and class fellows so that they can also get benefit of it, and introduce this channel to your respected teachers. I'll be waiting for your comments also. Now we can go through this 40, question number 40. Which statement does not describe redshift? What is redshift? When a planet is moving away from Earth or towards the earth, that is red shift. So moving toward you will be blue shift, like this one, and at rest will be this situation. So first situation is this one, upper one, which is moving towards you, and the second, when it is at rest, this will be the situation, and red shift will be this one, moving away from you, this portion. So hopefully you understood this as well. And A option, all the light emitted from all distant galaxies is at the red end of the spectrum. So you can see distant galaxies will be at the red, all the distant galaxies in at the red end of the spectrum. This is red end of the spectrum. So you can see this is on this side, this side. If you check, this is not more than this, and this is also to this side. So if you compare these situations, these three situations, you can understand this behavior. This line, black line, is to the right. So that's why we have taken option A. Hopefully you understood this. More students are watching the video, but they forget to subscribe channel. So don't forget, and help your friends, and recommend this channel to your friends, and share the videos. Thank you very much for watching. Take care. Bye.